Good evening, everybody. And today we are going to attempt the exercise 8D. This is the second episode on this exercise. The topic of the exercise is rates of change. The chapter is further differentiation. We are solving the course book of the Pure Maths 1. This is Cambridge AS A levels. Mathematics 9709. This is the subject. It's paper one. We are covering the course book related with the paper one. And this is our second episode on this. So let's start. The question number we have done already 1x1. So here you go. Question number 6 showing up on your screen. He says a point is moving along the curve y equals to 2 divided by x plus 5x in such a way that the coordinate is increasing at a constant rate of 0.02 units per second. Find the rate at which the y coordinate is changing when x is equals to 2, stating whether the y coordinate is increasing or decreasing. So this is the question number 6. I hope it's visible to you. So let's start. So question number 6, we are talking about the question number 6 here. The equation is given. Y is equals to 2 divided by the x plus 5x. The rate of the change of the x is given. The dx by the dt is given. That is equals to 0.02 units, 0.02 units per second. This is given. And find the rate at which the y coordinate is changing when the x is equals to 2. He says when the x is equals to 2. Okay, this is question number 3. Then we have to decide whether the y is increasing or decreasing. Okay, so this is the question. Now, what we will do, we will take, I will take the y and I will find its derivative, okay? So, dy by the dx, the y is given here, y is equals to 2 divided by the x plus 5x. The friendly form will be 2 into the x raised to power minus 1 plus 5x. So, my y will be dy by the dx will be equals to 2 into the minus 1 into the x raised to power minus 2 plus 5. We have taken the derivative. So my dy by the dx will be equals to minus 2 divided by the x square plus 5. So at x is equals to 2, it is given. The dy by the dx will become minus 2 divided by 2 and its square plus 5. So this will be minus 2 by 4 plus 5. So the dy by dx will be 1 by 2 plus 5 minus 1 by 2. So it will be 4 whole, that is 9 by 2. So the value of the dy by the dx at x equals to 2 is this. So question number 6, and they said, okay, now we have to find out the rate of increase of or decrease of the y. So for that purpose, I will apply the chain rule. The chain rule says that the dy by the dt, that will be equals to dy by the dx into the dx by the dt. Dy by the dx we just found, that is 9 by 4. That's 9 by 2, sorry. 9 by 2 into dx by dt is already given as 0.02. 0.02. Okay, so it will be the answer will be 0.09 units per second. Okay, so the dy by the dt, this is the rate of change of the y with respect to the time. Okay, so let me check the answer, sir, from the book. Exercise 6, 0.09 units per second. You know, because the because this number is positive. You see, the because this is positive, so that means that it is increasing. Okay, so that means it's increasing. The rate of change of y is increasing because the dy by dt is positive. So that means it's increasing. This is what my understanding is. Okay, that's right, sir. So this is how you will do the question number. Uh, the question number. The question number 6. Okay, the question number 6 showing up on your screen. So let's do the next one. The next one is the question number 7. Question number 7. So question number 7. Question number 7. Okay, the question number 7. Let me show you. I can show you here. Question number the 7. The point moves along the curve y is equals to 8 divided by 7 minus 2x. As it passes through the point P, the x coordinate is increasing at a rate of 0.125 units per second, and the y coordinate is increasing at a rate of 0.08 units per second. Find the possible x coordinate of the P. Okay, the values of the here, question number 7. The y is equals to 8 divided by 7 minus 2x. Okay, the dx by the dt is given. This is 0.125 units per second, and the dy by the dt is also given. That is equals to 0.08 units per second. This is the data given. Okay, a point moves along the curve y is equals to 8 divided by 7 minus 2x. As it passes through the point P, the x coordinate is increasing at a rate of 0.125 units per second, and the y coordinate is increasing at a rate of 0.08 units per second. Find the possible x coordinates of the P. Okay, we have to find out the value of the x. Okay, now I will take the y and I will derivate it. You know the y is equals to 8 into 7 minus 2x raised to power minus 1. Okay, y is equals to, I wrote it in a friendlier shape, so I can derivate it. Okay, so I will derivate it. So my dy by the dx will be equals to 8 into minus 1 into 7 minus 2x raised to power minus 2, and then derivative of this will be 2. So my dy by the dx will be equals to, this will become minus 8 and plus minus 2. It will become 16 divided by the 7 minus 2x raised to power 2. Okay, so my dy by the dx is equals to this, and then I will apply the chain rule. You know the chain rule. Now I know the rate of change of the x. I also know the rate of change of y. So just apply the chain rule. I don't know. we can apply. So here we have dy by the dt is equal to the dy by the dx is equal into the dx by the dt. I know the value of the dy by the dt. I know the value of the dy by the dt. The value of the dy by the dt is this 0.08. Okay, 0.08. And dy by the dx value I don't know. I will find out. And dx by the, we have this expression for dy by dx. This is 0.125. So my dy by the dx will be equals to 0.08 divided by the 0.125. So my dy by the dx will be equals to, so what we will do, we will use calculator and we will try to find out the value. Okay, it's 0.08 divided by 0.125, and that is 0.64. So this value is 0.64. I know the expression for the dy by the dx, that is this expression. So in the place of this, I will put this expression. So 16 divided by 7 minus 2x raised to power 2 is equal to 0.64. So I will cross multiply it. So it will become 7 minus 2x whole square will be equal to 16 divided by the 0.64. So 7 minus 2x whole square will be equals to 16 divided by 0.64, that is equals to 25. Okay, I will take the square root on both the sides, so you will have plus minus 5. So now you have two options. 7 minus 2x is equals to plus 5. So minus 2x will be equals to 5 minus 7. Minus 2x will be equals to minus 2. X will be equals to 2. The other option will be 7 minus 2x is equals to minus 5. Minus 2x will be equals to minus 5 minus 7. Minus 2x will be equals to minus 12. Minus minus gone. X will be equals to 12 by 2. So the x value will be 6. So these are the two possible values. This was the question. So one value is this one, this value, this was 2 by 2. Sorry. So the x will be equals to 1. So the one value of the x is 1. The other value of the x at the point P can be 6. They ask us to find the two possible values. Okay. And this is the answer. So this is how you do the question number 7. So they ask us in the question number 7 to do to find the x coordinates of the point P, where the rate of the change of the y was given, the rate of the change of the x was also given, and we have to find the x coordinates of that point. So this is how you will do this question. This is the exercise 8D. This is our second episode on this exercise. The topic of the exercise is the rate of change, and the topic of the chapter is further differentiation. This is the solution of the course book of the Pure Maths 1. This is the paper 1 syllabus content related with the Cambridge International AS and A levels mathematics 9709. My name is Ferhan Mazher. So let's start the next one. Here we have question number 8 coming up on your screen. He says a point P travels along the curve y is equals to this in such a way that at time t minutes, the x coordinate of the P is increasing at a rate of 0.012 units per minute. Find the rate at which the y coordinate of the P is changing when the P is at the point 1, comma, minus 1. This is a simple, straightforward question. Okay, so let me erase this. First of all, let's erase this. Okay. So Okay. The question number 8, the curve is given. The y is equals to the cube root of the 2x square minus 3. 2x square minus 3. And the rate of change of the x is given. It is increasing. It is 0.012 units per second. Okay. We have to find out dy by the dt. The p coordinates are given that 1 comma minus 1. So we have to find out the dy by the dt. Okay. So find the rate at which the y coordinate of the p is changing when the p is at the point 1 comma minus 1. Okay. So very simple. What we will do, I will write that equation. So this is 2x square minus 3 raised to power 1 by 3. I will derivate this. Dy by the dx will be equals to 1 by 3 into 2x square minus 3 raised to power 1 by 3 minus 1. That will be minus 2 by 3. And then the derivative of this thing, that will be 2 into 2 into x minus 0. Okay. So this will become dy by the dx equals to, this becomes 4x. So this is basically 4x divided by the 3 into 2x square minus 3 raised to power 2 by 3. And this is how you will derivate this. Achha. So this is how you will. Battery down. Okay. So this is how you will derivate this. And okay. Okay. Charging पे लगा. मामा पास चले जाओ. मामा battery down हो गया. Oh, battery down हो गया. My youngest son is here. So it's 12 o'clock. He has not yet slept. So he's saying that the phone with which he was playing, its battery is down. Okay. Now we know the value of the x. Okay. At x equals to 1. Okay. At x equals to 1, the value of the x is 1. The dy by the dx, its value will become 4 into the 1 divided by the 3 into 2 into 1 square minus 3. The whole thing raised to power 2 by 3. So the dy by the dx will be equals to 4 ones are 4, 3 in the bracket 2 minus 1, that's minus 1 raised to power 2 by 3. So it will be dy by the dx, and because of the square it will become positive, so that's 4 by 3. Because the power is 2, so I think it's 4 by 3. Okay. Because of the power 2 by 3, that minus 1 has become positive 1. The multiply 3, that's 3. So 4 by 3. Now we will apply the chain rule. The chain rule is that the chain rule that says that the dy by the dx, dy by the dt will be equals to the dy by the dx into the dx into the dt. Okay. So dy by the dt I want to find out. Dy by the dx, its value is 4 by 3 into dx by the dt, its answer is 0.012. Okay, just multiply them. So dy by the dt will be equals to, very simple, straightforward, and it will become 0.04 and multiply with that becomes 0.16. So I think this becomes 0.16. Okay, that is, let me check then, units per second. Okay. I don't know. Let's check the answer, sir. 0.01. My okay. 0.016. Okay. Is 0.04. 0.04. Let me check. And the number, there is something wrong with the number. Let me see. 4 divided by 3 multiply with the 0.012. So, okay. So the answer is not 0. I did it mentally. So 16. This is the answer, sir. And it's the right answer. It matches with the book's answer. I just checked it on the calculator. Okay. 0.016 units per second. So we are working on the exercise 8D. And the topic of the exercise is rates of change, episode number 2 on this exercise. The last question we are working, there are total 9 questions in this exercise. And we are on the last question. He says, the point P, x comma y travels along the curve this, if y equals to x cubed minus 5x squared plus 5x in such a way that the rate of the change of x is constant. If the values of the x at the point where the rates of the change of the y is double the rate of the change of the x. Okay, so no problem. We will do this question. Let me show you that question. Okay, and it's a problem solving question. It's not clear. Okay. The question number 9 showing up on your screen. I hope you have read this. Okay. Now we are going to attempt this. I don't know. You will try. It's a problem solving type question. So it's a little bit difficult. It can be a little bit difficult, I mean. But we will try. Let's see what happens. So we are working on the exercise 8D. This is our second episode, and if I live to complete this question, then this exercise will be completed. So question number 9. So we're talking about the question number 9. He says y is equals to x cubed minus 5x squared plus 5x, and a point P, x comma y travels along the curve y equals to x cubed minus 5x squared plus 5x in such a way that the rate of the change of the x is constant. So dx by the dt, we don't know what is that rate. Let me call it A. Okay? Units per second. It is not given what is the rate. It says constant. Achha, then he says, find the value of x at the points where the rate of the change of the y is double the rate of the change of the dx of the x. So dy by the dt is double of this rate. So that is 2a units per second. Okay. So simple. It's very, very simple now. Just take that equation and that the equation of that curve and derivate it. Okay. So we will derivate it. So this is y is equals to the x cube minus 5x square plus 5x. So dy by the dx will be equals to the 3x square x plus 5. Okay. So dy by the dx will be equals to 3x square minus 10x plus 5. Okay. Then we can apply the chain rule. The dy by the dt, we can apply the chain rule. Dy by the dt is equals to, you know, the dy, that's the chain rule. The rate of change of y, dy by the dx into the dx by the dt. Okay. So the values were not given, but that they told us that the rate of the change of the x is constant and the rate of the change of the y is double that rate. Okay. So this is 2a, and we don't know this. Okay. This is a. So bring this here. So dy by the dx answer is 2a by the a, and that will be equals to 2. So now I know that the dy by the dx is equals to 2. So just bring the expression. Dy by dx, this expression we know here, that is 3x square minus 10x plus 5 is equals to 2. Bring this 2 to this side. 3x square minus 10x. It will become plus 3 equals to 0. 3 3s are 9, 9 1s are. Okay. I'm doing the midterm breaking. Okay. So I did the midterm breaking. I hope you know what is the midterm breaking. So x minus 3 minus 1 is common. X minus 3 is equals to 0. So x minus 3 and 3x minus 1 is equal to 0. So x minus 3 is equal to 0. So x will be equal to 3. 3x minus 1 is equal to 0. So 3x will be equal to 1. X will be equal to 1 by 3. So at one point where this will happen, the x coordinate will be 3. And on the other point where this will happen, where the rate of the change of the y will be double the rate of the change of the x, there the value of the x will be 1 by 3, and the other point the x value will be 3. And this is what they have asked us to do. So we are done with the question number 9 in the exercise 8D. There were 9 questions. We have done all the questions. We have made 2 episodes on this exercise. The episode number 1, in that episode, we have solved from question number 1 to 5. And in the second episode, which is right now we are recording, here we have done from question number 6 to question number 9. So your exercise 8D from the chapter number 8 is completed. The exercise 8D was about the rates of change, and the chapter 8 is about the further differentiation. We are solving the solution book of the Pure Maths 1, which covers the syllabus content of the paper 1 of the Cambridge International AS A-Levels Mathematics 9709. My name is Ferhan Mazher, and I am from Sargodha, Punjab, Pakistan. I hope that this video will be very helpful to you. If you think that this video is helpful to you, it has made your understanding better of your further differentiation, please like this video. If you think that this video can be helpful to some other students, please share the link of this video with them also. So thank you very much. It's not important that you come in the live because we are just recording this exercise solution. Our main aim is to get the recording of this video and post it in our channel so you can see the recorded video if you are in AS Mathematics. So thank you very much. Please share the link of this video on your WhatsApp, on your Instagram, on your Twitter, so that it can be helpful to so many students around the globe. Thank you very much for taking your time and watching this video. Have a good night, sir. God bless you all.